की भेजना मैंने।
So today topic is a bit easier. थोड़ी बहुत पुरानी basics of the IGCSE physics from electrical circuits. This is your topic number 4B and which is known as complete electrical circuit जिसके अंदर we'll be talking about many concepts including the series and parallel circuits to be starting off as well. We are all aware कि सीरीज सर्किट कैसा दिखता है, पैरेलल सर्किट कैसा दिखता है. अब इन दोनों में करंट एंड वोल्टेज किस तरह कैलकुलेट की जाती है एंड हाउ इज द रेजिस्टेंस कैलकुलेटेड इन सीरीज एंड पैरेलल सर्किट्स वी आर गोइंग टू कवर दिस टुडे एज वेल एंड देन वी विल बी डिराइविंग द इक्वेशंस फॉर combining the resistances in series and parallel as well. So the most important rules governing the measurements in electrical circuits are the conservation of charge and conservation of energies, which determine that how currents, voltages, and resistances change around any particular circuit. If we talk about current, current is the total amount of charge within a circuit which cannot increase or decrease when the circuit is functioning. Current क्या होता है? Basically, it is known as the flow of electrons. जब electrons flow करेंगे, you will have current. And the direction of current is always from positive to negative. We call this the conventional current. Currents are the measures of charge flow through a component, so they must be measured in the same line as the component as well. The ammeter must always be placed in series next to the component as well. कि अगर आपने इस बल्ब के अंदर करंट को मेजर करना है, then you have to measure it through a ammeter that you can see over here as well. ये आपका इस बैटरी कनेक्टेड है. बड़ी वाली लाइन is always the positive terminal. The smaller line always represents the negative terminal. तो जो करंट है वो मतलब कि इस डायरेक्शन में फ्लो कर रहा है थ्रू द कंपोनेंट्स. तो एम मीटर आपको बताएगा कि इस बल्ब में से कितना करंट फ्लो हो रहा है. द वोल्टेज विच इज सप्लाइड बाय द बैटरी उसको हम क्या कहते हैं? ईएमएफ. और जो वोल्टेज आपके कंपोनेंट्स तक पहुंचता है उसको हम पोटेंशियल डिफरेंस कहते हैं. सो द सम ऑफ ऑल पोटेंशियल डिफरेंसेस जो थोड़ा सा बल्ब को मिला, थोड़ा सा एमीटर को मिला, उन सब पोटेंशियल डिफरेंसेस को इफ यू ऐड दम अप यू विल गेट द टोटल ईएमएफ एज वेल. So, if we want to talk about how do we calculate the current in series circuits, any group of components that follow in a series in a circuit with no junctions in the circuit must have the same current through them all. So, current is always the same when we talk about a series सर्किट. करंट आपके पास सारे कंपोनेंट्स के अंदर सेम रहेगा अगर हम एक सीरीज सर्किट की बात कर रहे हैं. लेकिन इफ यू टॉक अबाउट द करंट्स इन अ पैरेलल सर्किट, whenever a current encounters a junction in a circuit the charges can only go one way or the other, so the current has to split. पैरेलल के अंदर अगर हम बात करें, द करंट विल बी शेयर्ड, या फिर आप उसको कह लो करंट विल बी डिवाइडेड. ये कब है? व्हेन वी आर टॉकिंग अबाउट अ पैरेलल सर्किट. बिकॉज आपके पास जब करंट एक आ रहा है लेट्स से 5 एम्पेयर का, आगे उसने दो कंपोनेंट्स के पास जाना है. नाउ दिस पॉइंट इज नोन एज अ जंक्शन. इस बल्ब को शायद 3 एम्पेयर चाहिए हो तो यहाँ पे आपके पास 2 एम्पेयर जाएगा. अब ये एक पैरेलल सर्किट है. बोथ ऑफ दीज सर्किट्स आर रनिंग पैरेलल टू ईच अदर एंड द करंट हैज बीन शेयर्ड राइट आफ्टर इट पास द जंक्शन एज वेल. So the proportions that travel along each possible path will be inverse proportional to the resistance along the path. मतलब कि जिस पाथ पे रेजिस्टेंस कम होगी उस पाथ पे आपका ज़्यादा करंट जाएगा. मतलब 5 में से लार्जर करंट 3 जो था वो कहाँ पे गया? लेसर रेजिस्टेंस वाली जगह पे. लेकिन जिस वायर पे इट गॉट अ हायर रेजिस्टेंस यू कैन सी कि वो 5 एम्पेयर में से सिर्फ 2 एम्पेयर went to the larger resistance one, क्योंकि lesser the resistance higher would be the current and higher the resistance lesser would be the current. तो higher resistance आपके पास इस वायर में थी, so you can see यहाँ पे सिर्फ 2 आया और ऊपर वाले में 3 एम्पेयर गया था आउट ऑफ द टोटल 5. गॉट इट?
जी।
गुड. सो है यू कैन सी कि आपके पास इस जंक्शन के अंदर 3 एम्पेयर ऐड हो रहा था. 3 एम्पेयर में से 2 एम्पेयर इधर गए और 1 एम्पेयर इधर एंटर हो गया. 2 एम्पेयर एंटर्ड हेयर, 1 एम्पेयर एंटर हेयर. इसका मतलब क्या है कि जहाँ पे 1 एम्पेयर गया है वहाँ पे कम रेजिस्टेंस थी या ज़्यादा रेजिस्टेंस थी?
ज़्यादा थे इसलिए एक ही गया
गुड.
था।
बिकॉज द रेजिस्टेंस वाज हायर एंड करंट वहाँ पे कम गया. एंड वाइस वर्सा कि यहाँ पे उसको कम रेजिस्टेंस मिली थी और करंट ज़्यादा गया. प्लस था भी आपके पास यहाँ पे एक बल्ब शायद कम रेजिस्टेंस की वजह से हो. और जब दोनों करंट्स वापस जंक्शन में ज्वाइन होंगे तो वो 2 + 1 एक बार फिर से 3 एम्पेयर बन के रिटर्न कर जाएंगे कहाँ पे? एट द नेगेटिव टर्मिनल. लेकिन करंट आया कहाँ से था? फ्रॉम द पॉजिटिव टर्मिनल. And if you need to talk about the voltages around the circuit, voltage का opposite scene होता है. Voltages are the measure of energy changes as the charge passes through a component. As such, they must be measured from one side to the other. For example, the voltmeter must always be placed in a parallel across to a component as well. And if we talk about a voltage in a series circuit, any group of EMFs that follow in series in a circuit with no junctions in the circuit, they will have a total EMF that is the sum of their individual values and account for the direction of their positive and negative sides. For example, two 1.5 volt cells in a TV remote will be in series so that they can supply an EMF of 3 volt. This is also true for any string potential differences. अगर एक बैटरी 1.5 की है और आपको 4.5 वोल्ट चाहिए तो आप तीन बैटरीज कनेक्ट कर लोगे इस तरह करके। और अगर आपको तीन चाहिए तो आप दो बैटरीज ऐसे करके कनेक्ट कर दोगे। या अगर आप तीन बैटरीज कनेक्ट करो, वो कितना हो जाएगा 4.5, और एक बैटरी आप उल्टी कनेक्ट कर दो, मतलब कि पॉजिटिव एंड को आप पॉजिटिव से कनेक्ट कर दो, तो वो -1.5 होकर दोबारा 3 ही बन जाएगा। 4.5 minus 1.5. So whenever we talk about EMF in a series, they add up. अगर आपने EMF इन सीरीज देखना है वो आपको हमेशा एड अप हो जाएगा। ये यू कैन सी आपके पास दो बैटरीज यहाँ पे कनेक्टेड है। अगर ये 6 वोल्ट है मतलब कि ये भी 3 वोल्ट की बैटरी है, ये भी आपके पास 3 वोल्ट की बैटरी है। सो पोटेंशियल डिफरेंसेस इन द सीरीज विल ऑलवेज एड अप। व्हाट शुड बी द टोटल पीडी अक्रॉस द टू रेजिस्टर्स इन दिस डायग्राम। अब इसका एड अप होके टोटल क्यों आ रहा है? अगर मैं देखूँ पोटेंशियल डिफरेंस इन बल्ब component 1 प्लस द पोटेंशियल डिफरेंस इन द component 2 would be equal to the total EMF supplied, which means that the voltage in a series circuit is shared. और अगर आप उन सारे शेयर्ड पोटेंशियल डिफरेंसेस को ऐड करोगे, इट्स गोइंग टू बी एग्जैक्टली इक्वल टू द total EMF. In the circuit diagram, the two voltmeters measure the potential difference in the circuit, and the total potential differences across the both resistors will be the sum of their individual potential differences. मतलब कि इस कंपोनेंट को 4 वोल्ट मिला, इसका पोटेंशियल डिफरेंस क्या था 4 वोल्ट, और इस वाले का पोटेंशियल डिफरेंस क्या था 2 वोल्ट। पोटेंशियल डिफरेंस क्या होता है? वो वोल्टेज जो कंपोनेंट्स को मिलता है। तो अगर आप 2 + 4 करोगे, इज दैट इक्वल टू द ईएमएफ। वो वोल्टेज जो बैटरी देती है उसको हम क्या कहते हैं? ईएमएफ। तो यस, वो दोनों को जब आप ऐड अप कर रहे हो, इंडिविजुअल पोटेंशियल डिफरेंस 1 और 2 को, दे आर बोथ एडिंग अप टू द टोटल ईएमएफ। गॉट इट?
जी।
एंड इफ यू टॉक अबाउट हाउ टू कैलकुलेट वोल्टेजेस इन पैरेलल सर्किट, वो किस तरह से वेरी करेंगे? इफ द टोटल वोल्टेज अक्रॉस एनी ब्रांच ऑफ अ सर्किट इज नोन, देन द वोल्टेज अक्रॉस एनी अदर ब्रांच इन पैरेलल with it will be identical as well. Voltage in parallel will always be the same. वो दोनों आपस में सेम होंगे। तो अगर हम करंट देखें सीरीज में वो सेम होता है, लेकिन करंट शेयर होता है पैरेलल में। यहाँ पे वोल्टेज शेयर कहाँ हो रहा है? पैरेलल में। लेकिन सेम किधर है? नहीं, वोल्टेज शेयर कहाँ हो रहा है? सीरीज में, लेकिन सेम कहाँ पे है? पैरेलल के अंदर। सो इट्स क्वाइट डिफरेंट फ्रॉम ईच अदर एज वेल। इफ यू टॉक अबाउट करंट फर्स्ट, और अगर वोल्टेज की हम समरी लें, करंट इन सीरीज, करंट इन पैरेलल, वोल्टेज इन सीरीज, वोल्टेज इन पैरेलल। तो करंट इन सीरीज जो है वो सेम होगा, पैरेलल में शेयर होगा। वोल्टेज इन सीरीज शेयर होगा और उनका टोटल ईएमएफ की इक्वल होगा, और पैरेलल में लेकिन वो सेम होगा। इज इट क्लियर?
जी।
सो वो अगर आपके पास ईएमएफ यहाँ पे 6 वोल्ट है, तो ये वाला वोल्ट मीटर कंपोनेंट 1 का भी 6 वोल्ट ही होगा, और ये वाला भी 6 वोल्ट ही होगा। यहाँ पे डिवाइड या शेयर वाला सीन होगा ही नहीं। सो दिस इज हाउ यू कैन सी दैट सीरीज एंड पैरेलल एक्चुअली डिफर फ्रॉम ईच अदर। नाउ लेट मी शो यू एज वेल वन थिंग। पहले हम सीरीज सर्किट को देखेंगे, और उसके बाद फिर हम पैरेलल सर्किट्स के ऊपर भी यहाँ पे इन डिटेल आएंगे एक दफ़ा।
A common point of confusion in exams is the differences between series and parallel circuits. In a series circuit, we only have a single loop, and the components are all connected one after the other. On the other hand, parallel circuits contain more than one loop, and this small difference completely changes how we measure current, voltage, and resistance. In this video, we'll discuss series circuits and some of the calculations that you might have to do. Then in the next video, we'll consider parallel circuits. So with this series circuit, Because all the components are in a single loop, if any one of them is disconnected or broken, the whole circuit will stop working. This is a really big downside, and so in practice, very few things are actually connected in series. Another thing to know is that the potential difference of the cell or battery is shared across all of the components. You might sometimes see this shown as an equation like this, which just shows that the total voltage is equal to the voltages across all of the individual components. So the first component plus the second component, and so on. So if our battery here had a potential difference of 12 volts, and the only components are these two lamps, then the voltage across the two of them must add up to 12. For example, if these two lamps were slightly different models, and the voltage measured across one of them was 8 volts, then there must be 4 volts across the other one, as 8 plus 4 is 12. Whereas if both lamps were identical and had the same resistance, then the voltage must be 6 across each of them, because they would each get half of the 12 volts. Current, meanwhile, is the same everywhere in the circuit, no matter where you look. We measure current using an ammeter, which we place in series, so within the main loop. And because the same current flows through all of the components, we can put the ammeter anywhere. For example, instead of putting it down here, we could put it up on one of the sides. It really doesn't matter. We could also calculate the current by dividing the total potential difference by the total resistance, which is just a rearranged form of Ohm's law. Resistance is similar to potential difference, in that the total resistance is just the sum of the individual resistances of each component. This green symbol just means sum, so total, and you sometimes see it in physics and maths papers. As an example, let's imagine that this lamp on the left had a resistance of 4 ohms, and the other one had a resistance of 2 ohms. The total resistance of our circuit would have to be 4 plus 2, so 6 ohms. Now that we know the total resistance of our circuit, we can use Ohm's law to calculate the current by taking the potential difference of our battery, so 12 volts, and dividing it by our total resistance of 6 ohms, to give us a current of 2 amps. One thing to be aware of is that ammeters generally have such tiny resistances that we can ignore them in our calculations, which is why we haven't included anything for the ammeter. The next thing we need to look at is how to calculate the voltage across a single component in a circuit. We just worked out that the current in the circuit is 2 amps. And remember that with current, it doesn't matter whether you're looking at the circuit as a whole or at an individual component. The current is always the same. So we can use that current and the resistance of a specific component to find its individual share of the voltage in the circuit. For example, this lamp on the right has a resistance of 2 ohms, and the current across it must be 2 amps. So using our Ohm's law equation again, we can see that the potential difference must be 2 amps multiplied by 2 ohms. So there must be 4 volts across this specific lamp. To find the voltage across the other component, we could do the same thing again, or because we know that the total voltage must be the same as the battery, which was 12 volts, we can just do 12 minus 4 to find that this other lamp must have a potential difference of 8 volts. Or if you don't like maths, the final way we can find the voltage is just to use a voltmeter, which we connect in parallel across the component we're looking at. So this one would give us a reading of 8 volts. Even though voltmeters are in parallel, we'd still treat the overall circuit as being series. As a final point, it's good to remember that due to Ohm's law, those components with a greater resistance will always have a higher share of the voltage. You can think of this in terms of more force being required to push the charge through the areas of highest resistance. This is why our 4 ohm resistor had 8 volts of the overall potential difference, but our 2 ohm resistor only got 4 volts. Anyway, that's everything for this video.
So is the series circuit clear? Can you tell me current or voltage कैसे वेरी करते हैं in a series circuit?
सीरीज सर्किट में करंट एक जैसी होता है, पूरा सर्किट में
हम्म
कंसिस्टेंट होता है। वोल्टेज वेरी करता है, डिपेंड मतलब रेजिस्टेंस पे।
गुड, ठीक है। Alright. Now let's look at the parallel circuits.
In today's video, we're going to explore parallel circuits, and in particular, we'll consider how they treat potential difference, current, and resistance. Parallel circuits are those with more than one loop, and generally each loop will only contain a single component. This makes parallel circuits much more useful than series circuits, because as each component has its own loop, if any particular component breaks, then the overall circuit is still intact. For example, if one of the lights in your house blows, all of the other ones will still work. Often though, circuits will be a mix of series and parallel parts. So although we might have multiple loops, we could still have more than one component in some of those loops. If you're not sure what series circuits are, then it's probably worth checking out our video on that first. We put a link to it down in the description. Now, the first thing to know about truly parallel circuits, so those with only one component in each loop, is that all of the components get the full source potential difference. So if we have a 12-volt battery, then all of the components will have 12 volts across them. The next thing to know is that the current is shared between all of the loops. So if this circuit with 2 loops had a total of 4 amps flowing through it, then it could be that there were 3 amps flowing in the first loop and 1 amp through the second, or it could be equally split and have 2 amps flowing through each loop. Either way, if we add the currents in each loop together, it will always add up to the total current of the circuit, in this case 4 amps. The way that the current splits will depend on the resistance of the individual components in the circuit, with the loops that have greater resistance taking a lower share of the current. You can think of this as if the current is water flowing down a hill. If the water can flow down 2 possible paths, then most of the water, which represents electrical current, will take the path of least resistance, which is why we get a higher current flowing through the lower resistance loops. The last thing we need to look at is resistance. One strange thing about parallel circuits is that the more components we add in parallel, the lower the total resistance of the circuit will be. It's a pretty odd concept, and it could just be one of those facts that you have to accept and remember. But it might help to think about it in terms of our river example. Imagine that we add another possible route for the water to flow. Even if this route has a high resistance, it still increases the options for our water to flow, meaning that the water can flow down the hill more easily, which is the same thing as saying the overall resistance has decreased. So in physics terms, the more loops we add in parallel, the lower the overall resistance will be, even if those loops contain big resistors. Anyway, that's everything for today.
So can you tell me how does current and voltage vary in a parallel circuit?
पैरेलल सर्किट करंट वेरी करता है, जितना ज़्यादा, हाँ, वेरी करता है। और
Mm-hmm.
वोल्टेज इक्वल होता है,
Mm-hmm.
जितना ज़्यादा नहीं, कितना कम रेजिस्टेंस जितना ज़्यादा वोल्टेज होता है।
Good job, good job. All right. So next, if we discuss about resistance हमें पता है, it can be calculated by the Ohm's law V divided by I, and this can be done for any individual component or a whole branch of a circuit as long as the voltage and current are known as well. This also means that if we follow the rules for current and voltage variations around series and parallel circuits, we can come up with simple rules for the total resistance in series and parallel combinations as well. So if we talk about how to calculate resistance in series, you just saw in the video as well, any group of resistances that follow in series in a circuit with no junctions in the circuit will have a total resistance that is the sum of their individual values. And we can use the total potential difference across both the resistors and current flowing through them to calculate their total resistance as well. तो अगर आपने टोटल आर निकालनी है, आप उस सर्किट का, अभी हम सीरीज की बात कर रहे हैं, सीरीज का आप टोटल वी ले लो, वो है 6 डिवाइडेड बाय आई है, आई तो सेम होता है आपके पास सीरीज के अंदर, तो आपको आई टोटल तो नहीं लेना ना, वो आपके पास लेट्स से है 0.2, लेकिन आपको वी टोटल लेना पड़ेगा, द सम ऑफ पोटेंशियल डिफरेंसेस विच इज 6, ये डिवाइडेड एंड यूल गेट द आंसर ऑफ 30 ओहम एज अ रेजिस्टर। और अगर आपने रेजिस्टेंसेस को ऐड करना है, तो रेजिस्टर 1 की रेजिस्टेंस लेट्स से 10 है, रेजिस्टर 2 की लेट्स से 20 है, वो भी आपके पास 30 ओहम आ जाएगी। गॉट इट?
जी।
So the ammeters in series and voltmeters in parallel do not affect the resistances and can be ignored. Resistors in the series will have a total potential difference across them that is the sum of their individual potential differences. The current through them will be the same for each one, and take an example of the resistors in series as well. Potential difference अब आपको सीरीज के अंदर ऐड करके निकालना पड़ेगा, क्योंकि सीरीज में पोटेंशियल डिफरेंस तो शेयर हो रहा होता है। जब आपके पास ये वी टोटल आ जाएगा, इसको आपने डिवाइड करना है करंट से। अब करंट टोटल जैसी कोई चीज़ होती नहीं रजिस्टर में, क्योंकि करंट तो सेम है, आपने अभी बताया था सीरीज में। फिर आप अपनी टोटल आर आप निकाल सकते हो बाय वी टोटल डिवाइडेड बाय करंट। और अगर आपके पास रेजिस्टेंसेस सारी हर कंपोनेंट को दी हैं, तो फिर वी और आई का चक्कर ही नहीं है, सारे रेजिस्टर्स की रेजिस्टेंसेस को बस आप ऐड कर दो and you can calculate the resistances in the series as well. And if we talk about how to calculate the resistors in parallel, the total resistance of a group of resistors in parallel can be calculated from the equation is which is equal to 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 and so on. जैसे कि अगर आपके पास ये एक सर्किट डायग्राम है, आपके पास तीनों रेजिस्टेंसेस क्या क्या दी हुई हैं, कैन यू टेल मी?
16, 24, 48।
गुड। तो हम कैसे निकालेंगे? 1/16 प्लस 1/24 प्लस 1/48। ठीक है, अब आप एलसीएम ले लो, एलसीएम जो आप लोगे तो क्या आ जाएगा? 48। ऊपर आप लिख लें 3 2 1, फिर 3 + 2 + 1 किया, 6/48 आ गया। अब आप कैंसिल आउट कर दो, 6 1 जार 6, 6 8 जार 48, 1/RT इज इक्वल टू किसके आ गया? 1/8 के। मतलब कि दोनों का रेसिप्रोकल ले लो, दोनों को ऊपर ले जाओ, तो क्या बनता है? टोटल रेजिस्टेंस इज इक्वल टू व्हाट?
8 ohms।
8 हो गया है। So resistors in parallel will always have a total current through them that is the sum of their individual currents. अब हमें पता है कि जब आपको पैरेलल के अंदर टोटल रेजिस्टेंस निकालनी है ना, तो आपका V सेम होगा, लेकिन I जो होगा दैट वुड बी द टोटल, क्योंकि I आपने कहा था कि पैरेलल के अंदर तो शेयर होते हैं। नाउ वी हैव टू ऐड अप ऑल द इंडिविजुअल करंट्स, लेकिन वोल्टेज एक ही होता है, वोल्टेज टोटल नाम की चीज नहीं होती पैरेलल में, बिकॉज वोल्टेज इज द सेम इन पैरेलल। इट वाज डिफरेंट इन सीरीज, इसलिए हमने उसका टोटल लिया था, बट इट इज द सेम इन पैरेलल। करंट सीरीज में सेम था, तो हमने सिर्फ करंट ले लिया, लेकिन यहाँ पे हमें करंट टोटल निकालना पड़ेगा, क्योंकि पैरेलल के अंदर करंट्स आर बीइंग शेयर्ड। वंस आप वो सारे निकाल लोगे, देन यू कैन ऑल्सो कैलकुलेट योर रेजिस्टेंस बाय यूजिंग वोल्टेज एंड करंट। गॉट इट?
जी।
So, if a circuit has a mix of series and parallel combinations, we must use the rules that we have for each group of resistors. Then we should use the rules again to combine the subtotals. पहले आपको चाहिए कि आप parallel में इन दोनों का निकाल लो। Parallel में अगर दो resistor हैं, तो एक और तरीका होता है R1 multiplied by R2 divided by R1 plus R2. This is only when आपके पास दो resistors given हो in parallel circuit। आप जब इसकी निकाल लोगे, फिर आप इसको इसमें ऐड कर देना सीरीज के तौर पे, and then you can also solve this question as well. So if we talk about current, in a series circuit, current is the same throughout, but in parallel, you have to take the sum of all currents total. Voltage आपके पास parallel में it's gonna be the same, but series में you have to combine all the individual potential differences to calculate the total EMF. Resistances आपने simple add करनी है in series, but you have to take a reciprocal when we are talking about parallel circuits. Got it?
जी।
All right. Let me
When you write, your tone influences how readers respond. With Grammarly, just highlight your text and type how you want to say.
There are two main types of electrical circuit: series and parallel. In a series circuit, the components are connected end to end, one after the other. They make a simple loop for the current to flow round. In a parallel circuit, the components are connected side by side, so the current divides, some going one way and the rest the other way. Here's an example of two circuits, both containing a cell and two bulbs. One circuit is series, the other is parallel. The voltage is a measure of the electrical push that the battery gives to the electrons. It's a measure of the energy in joules given to each packet of electrons, coulombs. So the voltmeter measures joules per coulomb, or volts. Voltmeters are always connected in parallel when added to a circuit. In this diagram, the voltmeter is measuring the voltage across the lamp. We can also measure the current flowing through a circuit. In a wire, the current is the flow of negatively charged electrons. We can imagine it being like water flowing in a pipe, but instead of water, it's a flow of electric charge, which we measure in coulombs. So electric current is coulombs per second, or amps, measured using an ammeter, which must be connected in series. Resistance is a measure of the opposition to current flow in an electrical circuit. Resistance is measured in ohms, symbolized by the Greek letter omega. The higher the resistance, the more difficult it is for a current to flow. A good way to think about electricity is voltage as the force pushing the current around, and resistance is as if the pipe carrying the current narrows. For components connected in series, the total voltage or potential difference of the power supply is shared between the components. There is the same current through each component. The total resistance of two components is the sum of the resistance of each component. For components connected in parallel, the voltage or potential difference across each component is the same. The total current through the whole circuit is the sum of the currents through the separate components, and the total resistance of two resistors is less than the resistance of the smallest individual resistor. Let's have a go at applying some of those rules. Each cell provides a potential difference of 1.5 volts. What's the potential difference provided by the four cells in the circuit? What will be the reading on the voltmeter? The current through the lamp is 0.20 amps. The current through the resistor is 0.10 amps. What is the reading on the ammeter? Pause the video while you work out the answers. When resistors are in parallel, things work out a bit different. Look at this circuit. If these two resistors were in series, then their combined value would be 3 ohms plus 3 ohms equals 6 ohms. But when in parallel, we use this formula. In this example, we have if 1 over R equals 2 over 3, then R equals 3 over 2 equals 1.5 ohms. The total resistance is lower than each individual resistor. Try this one. One over R equals 1 over 10 plus 1 over 5, which equals 3 over 10. So R is 10 over 3, which equals 3.33 ohms. How did you do? So now you know how series and parallel circuits differ and how we can calculate the resistance experimentally.
ऑलराइट, समझ आ गया।
जी।